This video is Chapter 6, Part A, Dictionaries. In this chapter, you'll learn how to use Python's dictionaries, which allow you to connect pieces of related information. You'll learn how to access the information once it's in a dictionary and how to modify that information. Because dictionaries can store an almost limitless amount of information, I'll show you how to loop through the data in a dictionary. Additionally, you'll learn to nest dictionaries inside lists, lists inside dictionaries, and even dictionaries inside other dictionaries. Understanding dictionaries allows you to model a variety of real-world objects more accurately. You'll be able to create a dictionary representing a person and then store as much information as you want about that person. You can store their name, their age, their location, profession, and any other aspect of a person you can describe. You'll be able to store any two kinds of information that can be mashed up, such as a list of words and their meanings, a list of people's names and their favorite numbers, a list of mountains and their elevations, anything you can think of. You can put it in a dictionary. Dictionaries are something you haven't seen in Scratch, and they are something that maybe you wouldn't think you want to learn, and yet they unlock all sorts of practical things. There's a reason we are learning them right after conditional statements. In some ways, they act as shortcuts to conditional statements. Dictionaries allow me to include more information in a variable than just what it is. For example, in the list of cars we were working with earlier, it might be helpful to categorize them according to year and color. It's not just a BMW, it's a red BMW, which is interesting. And I could call the whole string red BMW. But what if those bits of data matter to the program? Perhaps I'm writing a racing game, and a Ferrari and a Lamborghini have speed ratings of 5, and a dump truck has a speed rating of 1. I can make the game respond according to the speed rating without having to test it. Is it a Ferrari or a Lamborghini or an Aston Martin or a dump truck? By the way, I would also have a crash rating, and a dump truck would have a 5, while the fast cars would have a 1, so I could have the dump truck pulverize anything it could catch up to. Fun game. But the point is, I can use a dictionary to add extra attributes to things. In a few chapters, we will build on the idea of dictionaries to develop something called classes, which is a key component in object-oriented programming, which is a buzzword that is used to distinguish the real programmers from the tinkerers. Most everyone who knows what they're doing uses OOP. So, work to figure this out, because this is a foundation you will build on to learn more complex things. We begin with a simple dictionary. Consider a game featuring aliens that can have different colors and point values. This simple dictionary stores information about a particular alien. The dictionary, Alien 0, stores the alien's color and point value. The two print statements access and display that information as shown here. As with most new programming concepts, using dictionaries will take practice. Once you've worked with dictionaries for a bit, you'll soon see how effectively they can model real-world situations. A dictionary in Python is a collection of key-value pairs. That's an important term. Each key is connected to a value, and you can use a key to access the value associated with that key. A key's value can be a number, a string, a list, or even another dictionary. In fact, you can use any object that you can create in Python as a value in a dictionary. In Python, a dictionary is wrapped in braces, those curly bracket looking things, with a series of key value pairs inside the braces. The key is followed by a colon, and then the value. A key value pair is a set of values that are associated with each other. When you provide a key, Python returns the value associated with that key. Every key is connected to its value by a colon, and individual key value pairs are separated by commas. You can store as many key value pairs as you want in a dictionary. The simplest dictionary has exactly one key-value pair, as shown in the modified version of Alien 0. This dictionary stores one piece of information about Alien 0, its color. The string color is the key, and the value is green. To get the value associated with a key, give the name of the dictionary, and then place the key inside a set of square brackets as shown here. This returns the value associated with the key color from the dictionary Alien 0. Notice that this is just one value, so I could store it in a variable and or run conditional tests according to the color of the alien. You can have an unlimited number of key value pairs in a dictionary. For example, here's the original Alien 0 dictionary with 2 key value pairs. Now you can access either the color or the point value of Alien 0. If a player shoots down this alien, you could look up how many points they should earn using code like this. Once the dictionary has been defined, the code at 1 pulls the value associated with the key points from the dictionary. The value is then stored in the variable new points. The line at 2 converts the integer value to a string and prints a statement about how many points the player just earned. You just earned 5 points. I could also use this to add those points to a total score or something like that. If you run this code every time an alien is shot down, the alien's point value would be retrieved. Dictionaries are dynamic structures, and you can add new key value pairs to a dictionary at any time. For example, to add a new key value pair, you would give the name of the dictionary followed by the new key in square brackets along with the new value. Let's add 2 new pieces of information to the Alien 0 dictionary. The alien's X and Y coordinates, which would help us display the alien at a particular position on the screen. Let's place the alien on the left edge of the screen, 25 pixels down from the top. Because the screen coordinates usually start at the upper left corner of the screen, we'll place the alien on the left edge of the screen by setting the X coordinate to 0 and 25 pixels from the top by setting its Y coordinate to 25, as shown here. We start by defining the same dictionary that we've been working with. We then print this dictionary, displaying a snapshot of its information. At 1, we add a new key value pair to the dictionary. Key, X position, and value, 0. We do the same for key, Y position, at 2. When we print the modified dictionary, we see the 2 additional key value pairs. The final version of the dictionary contains 4 key value pairs. The original 2 specify color and point value, and 2 more specify the alien's position. Notice that the order of the key value pairs does not match the order in which we added them. Python doesn't care about the order in which you store each key value pair. It only cares about the connection between each key and its value. Let me say that again. Python doesn't care about the order in which you store each key value pair. It cares only about the connection between each key and its value. It's sometimes convenient, or even necessary, to start with an empty dictionary and then add each new item to it. To start filling an empty dictionary, define a dictionary with an empty set of braces, and then add each key value pair on its own line. For example, here's how to build the Alien 0 dictionary using this approach. Here we define an empty Alien 0 dictionary and then add color and point values to it. The result is the dictionary we've been using in previous examples. Typically, you'll use empty dictionaries when storing user-supplied data in a dictionary, or when you write code that generates a large number of key value pairs automatically, perhaps 30 aliens. To modify a value in a dictionary, give the name of the dictionary with the key in square brackets and then the new value you want associated with that key. For example, consider an alien that changes from green to yellow as the game progresses. We first define a dictionary for alien 0 that contains only the alien's color. Then we change the value associated with the key color to yellow. The output shows that the alien has indeed changed from green to yellow. For a more interesting example, let's track the position of an alien that can move at different speeds. We'll store a value representing the alien's current speed and then use it to determine how far the right, We'll store a value representing the alien's current speed and then use it to determine how far to the right the alien should move. We start by defining an alien with an initial x position and y position and a speed of medium. We've omitted the color and point values for the sake of simplicity, but this example would work the same way if you included those key value pairs as well. We also print the original value of x position to see how far the alien moves to the right. At 1, an if-elif-else chain determines how far the alien should move to the right and stores this value in the variable x increment. If the alien's speed is slow, it moves 1 unit to the right. If the speed is medium, it moves 2 units to the right. And if it is fast, it moves 3 units to the right. Once the increment has been calculated, it's added to the value of x position at 2, and the result is stored in the dictionary's x position. Because this is a medium speed alien, its position shifts 2 units to the right. Original x position 0, new x position 2. This technique is pretty cool. By changing one value in the alien's dictionary, you can change the overall behavior of the alien. For example, to turn this medium speed alien into a fast alien, you would add the line alien 0 speed equals fast. The if-elif-else block would then assign a larger value to x increment the next time the code runs. When you no longer need a piece of information that's stored in a dictionary, you can use the del statement to completely remove a key value pair. All del needs is the name of the dictionary and the key that you want to remove. For example, let's remove the key points from the alien 0 dictionary along with its value. Alien 0 equals color green points 5. Print alien. The line at 1 tells Python to delete the key points from the dictionary alien 0 and to remove the value associated with that key as well. The output shows that the key points and its value of 5 are deleted from the dictionary, but the rest of the dictionary is unaffected. Be aware that the key value pair is removed permanently. The previous example involves storing different kinds of information about one object, an alien, in a game. You can also use a dictionary to store one kind of information about many objects. For example, say you want to poll a number of people and ask them what their favorite programming language is. A dictionary is useful for storing the results of a simple poll, like this. As you can see, we've broken a larger dictionary into several lines. Each key is the name of a person who responded to the poll, and each value is their language choice. When you know you'll need more than one line to define a dictionary, press Enter after the opening brace. Then indent the next line, one level, which is 4 spaces, and write the first key value pair followed by a comma. From this point forward, when you press Enter, your text editor should automatically indent all of the key value pairs to match the first key value pair. Once you finish defining the dictionary, add a closing brace on the new line after the last key value pair and indent it one level so it aligns with the keys in the dictionary. It's good practice to include a comma after the last key value pair as well, so you're ready to add a new key value pair on the next line should you need to do so. The previous example involves storing different kinds of information about one object, an alien in a game. You can also use a dictionary to store one kind of information about many objects. For example, say you want to poll a number of people and ask them what their favorite programming language is. A dictionary is useful for storing the results of a simple poll, like this. As you can see, we've broken a larger dictionary into several lines. Each key is the name of a person who responded to the poll, and each value is their language choice. When you know you'll need more than one line to define a dictionary, already said that. Here we go. To use this dictionary, given the name of the person who took the poll, you can easily look up their favorite language. To see which language Sarah chose, we asked for the value at favorite languages, Sarah. This syntax is used as the print statement at 2, and the output shows Sarah's favorite language. Sarah's favorite language is C. This example also shows how you can break up a long print statement over several lines. The word print is shorter than most dictionary names, so it makes sense to include the first part of what you want to print right after the opening parenthesis. Choose an appropriate point at which to break what's being printed. Add a concatenation operator at the end of the first line. Press Enter and then press Tab to align all of the other lines in one indentation level under this print statement. When you've finished composing your output, you can place the closing parenthesis from the last line of your print block. And then we come to the assignments for 6A. Take your time. Make sure you really understand how you're creating these dictionaries and accessing them to print. The next couple of lessons will be about how to store dictionaries in dictionaries and use them in more complicated ways. So it's really important. Make sure you understand this section about how this basic dictionary works.